All right, I asked you to do questions 1 to 6 on the sheet for homework. Okay, in our electrostatics preview, maybe as opposed to review. So question 1 says two charges Q1 and Q2 are separated by a distance r and exert a force F on each other. Okay, so that's using the equation FQ is equal to K Q1 Q2 over r squared. So part A says, what happens if Q1 is doubled? Well, if Q1 is doubled, FQ should double. Okay? What happens if both Q1 and Q2 are cut in half? Well, if Q1 is cut in half, F will be cut in half. And if Q2 is cut in half, F will be cut in half. So if they're both cut in half, F should be a quarter. What happens if R is tripled? If R gets bigger, F's going to get smaller. If R gets bigger by a factor of 3, F is going to get smaller by a factor of 9 because of the squared. And so FQ should be 1/9 of what it was. What happens if R is cut in half? If R gets smaller, FQ should get bigger. If R is cut in half, that will get, gets squared, and so FQ should get bigger by a factor of 4. So it should be 4 times as big. What happens if Q is tripled? One of the Q's is tripled. FQ should triple. And if the R is doubled, if R gets bigger, FQ is going to get smaller. If R gets bigger by a factor of 2, FQ should get smaller by a factor of 4. So the overall result is that it should be 3/4 the size that it was. Okay, so you don't really need to use any numbers or any of those. You just need to kind of look at the equation. Uh-oh. I thought I didn't give you one with an electron because I didn't tell you the charge on an electron. So as an aside that you might want to add in your notes, one elementary charge, because electrons and protons are the elementary charge. One elementary charge has a size of plus or minus, depending on if it's a proton or electron, 1.602 times 10 to the negative 19 coulombs. When they first found the electron and the proton, they thought it was the tiniest possible unit of charge. We now know it isn't, but we still call it an elementary charge. This E here is not for electron, it's for elementary. Okay, and you needed to know the charge on an electron because it says 2 electrons. Both then would have a charge of 1.602 times 10 to the negative 19 coulombs, and of course it would be negative, are separated by a distance, r, is equal to 1.5 times 10 to the negative 10 meters. In a typical size atom, what is the force between them? So FQ is equal to KQQ over r squared, so 9 times 10 to the 9th Newton meters squared per coulomb squared times 1.602 to the negative 19 coulombs. It's negative, but it's really going to get, I'm going to put a squared there rather than write it out because I'll go out of the screen. And then the R is 1.5 times 10 to the negative 10th meters, and it's squared. This square comes from the fact that it's QQ, and the two Q's are the same. Assuming you could type this in your calculator correctly, you should get 1.027 times 10 to the negative 8 newtons. Okay? Number 3. Sorry about that charge on the electron. Object A has a charge of 1.8 mu Cs, 1.8 microcoulombs. That is 1.8 times 10 to the negative 6 coulombs. A coulomb is huge, so most times the charges are in microcoulombs. And charge B has a charge of negative 1 microcoulomb, so 1 times 10 to the negative 6 coulombs. And they are 14 millimeters apart. So R is 14 millimeters, or 14 times 10 to the negative 3 meters. And yes, I know that's not in proper scientific notation. What is the force on charge A? So FQ is equal to KQQ over R squared. 9 times 10 to the ninth Newton meter squared per Coulomb squared times 1.8 times 10 to the negative 6 coulombs times negative 1 times 10 to the negative 6 coulombs divided by 14 times 10 to the negative 3 meters squared. FQ equals, when you do this, you're actually going to get a negative 82.65 newtons. Now, you know in physics we always have to say what the negative means, and I forgot to tell at least the first half of the class. The negative is going to mean what's going to happen between a positive charge and a negative charge. They're going to attract. So negative on a force is a force of attraction, and positive is a force of repulsion. Now you might think that's weird, that it should be that positive is force of attraction. Really, it's made specially for me. It's made specially for me because if you're a nun, a force of attraction is a negative thing. If you're in a relationship and you feel a force of attraction to someone else, it's a negative thing. So force of attraction, negative thing. So if you get a negative F, it means it's a force of attraction. Number 4, two negatively charged objects, and they're the same. So Q1 equals Q2 equals negative 5 times 10 to the negative 5 coulombs. Are 0.2 centimeters from each other. The R, maybe it's 0.2 meters. What is the force? Oh, sorry, I didn't quite finish the one above, because it asks what's the force on object A, and then what's the force on object B. Newton's third law tells us this should be the force on both of them, right? One can't put a force on the other if the other doesn't put it back. So both of them are experiencing a force of attraction of 82.65 meters. All right, so this one is, what is the force that acts on each particle? Again, it's going to be the same. So K Q1 Q2 over R squared. So 9 times 10 to the ninth Newton meters squared per Coulomb squared times negative 5 to the negative 3. No, it's really negative 5. I could make up my writing. And they're the same, so I'm going to square it, over 0.2 meters squared. It's going to work out to be a positive value, which means it's going to be a force of repulsion, which it should be because they're the same charge, same nature. 562.5 newtons, and that is a force of repulsion. Number 5. Two charged objects can exert a force of repulsion, FQ, of 2 newtons on each other. If each charge, Q1 and Q2, is negative 3 microcoulombs, how far apart are they? So FQ equals KQ1 Q2 over R squared. So R squared equals KQ1 Q2 over FQ. So 9 times 10 to the ninth Newton meter squared per Coulomb squared times negative 3 to the negative 6 coulombs, and they're both the same, so squared, over 2 newtons. FQ is equal to, R is equal to, don't forget to take the square root, 0.2012 meters. If you get 0.0405, you forgot to take the square root. And the last one, number 6, an object with a charge, so Q1, of 1.92 times 10 to the negative 6 coulombs, because it says microcoulombs. And the second one is negative 2.56 to the negative 6 coulombs. Exert an attractive force, FQ, of 4 newtons on each other. It's attractive. It has to be a negative. And you're solving for R again. I'm going to run out of time. R squared is equal to KQQ over FQ. So R squared is equal to 9 times 10 to the ninth Newton meters squared per Coulomb squared. 1.92 to the negative 6. Negative 2.56 to the negative 6 over 4 newtons, and it's negative. Take the square root and you should get an R of 0.1052.